Hi, this is a video showing how we go from an exponential function to a quadratic function. So basically algebraic functions in real life settings. This real life setting is the coronavirus, as we are all living through that right now. These graphs were taken, I took these off the internet on the 15th of April. Um, at 5 p.m. So you're going to see that the first one I was so big that I had to put it together. But I wanted you to see this because we started off in the middle of the year. We talked about exponential functions first in Algebra 1. We didn't do too much with them. We basically talked about exponential growth and decay. And an exponential function is a function that goes one direction and it just continues in that direction. So here are how some of the curves, the early curves were for our countries. And I needed two because if you see the United States curve is going way higher than our other curves for European countries, which is interesting. And then you have these flat curves right here that are showing us where they sort of level off. Now, any of these curves, whether it's steep or not so steep, they don't look like they're changing directions. But in the real world, what goes up eventually, we hope, will come down. So you're seeing this is a larger picture because if you look down on the bottom of this, you're going to see that this takes us out to October and January next year. Now, if if we were to stay on the current track, it says that this model predicts that roughly a third of Americans, more than 100 million people, could become infected, including more than 9 million at one time. So this is the infected curve. The much lower curve is our total death. So you can see from these curves that the mortality rate is less, but it looks like it's not changing over time, which I believe is what would happen if we did nothing. Now, we're in April 2020. So everything after April 2020 is a guess. So I looked at more graphs. All right, and if you watch the news at all, you hear about this term flattening the curve. So if we look here, you see two quadratic functions. This is supposed to represent a function if we don't do anything. If we were just to let the coronavirus run its course and we still went to school, we still went shopping and did everything, then what's important to notice here is this line, this broken line, which says how many very sick people hospitals can treat. So that's a maximum right there. And if you look, if we do nothing, our maximum far exceeds the maximum that hospitals can treat. So the reason that we talk about flattening the curve is because we want our quadratic function to max out at the same point that the hospitals can max out. All right, the hospital is a constant function because their number of beds don't change. However, our number of beds do continue. I mean, our sick people, that number changes all the time. So what we're hoping is that if we do what we've been asked to do, we stay home, we're staying home from school, we're washing our hands, we're not we're not gathering with people, with a lot of different people. We're being really careful. We're not shaking hands or hugging. We're using social distancing. And this is why we want this curve to be here. Now, on the last video, I talked about the four key features and I color coded them. So I'm going to try to color code them here. I'm going to try to draw. Okay, we had the vertex, and the vertex, I'm using green for the vertex, and I don't know if this is going to, okay, this is my vertex. This is a vertex, and the vertex tells us in this case, the vertex tells us the highest number that it will get to before it changes directions. The flattening the curve model shows that our largest would be right under the hospitals. We don't want to go above that. And so this is what they're using. They're using this kind of math to tell us when it's safe to not stay home, when we can go back to school. Y'all, they're looking at quadratic functions, right? The other important one that we looked at was we looked at the, the solutions, or the x-intercepts. In this case, the x-intercept is where it starts. It's also our y-intercept, which I did in purple. Okay, so this point becomes our y-intercept and it becomes our x-intercept. And what it means in context is it means that this is where we began. Okay, this is the root, and then this is where we want to end. All right, now my thinking is that they just did this so it would be pretty. It would probably be more like this, and it would gradually go off a little bit more. So obviously an algebraic function makes a nice pretty curve, and real life doesn't, and I have one more to show you after this. All right, so our root is, the other root is to tell us when do we get out of this. All right, how long? So when we get here, this is what they're looking for, is somewhere here. We're way under where the hospitals could handle these numbers of people, and we won't risk going up again. Okay, we also talked about a vertex, or the axis of symmetry, which goes through the vertex. That basically just tells us at what point do we start changing directions. And then so we had a vertex, and the y-intercept is the same thing. So you see all four: our vertex, our root, our y-intercept, and our axis of symmetry. And basically that's just telling us, okay, once it goes up, it's going to come down. Okay, I'm going to go down a little bit further. Here's a real life example. This is the Bay Area. That's in the San Francisco area. The Bay Area is one of the first areas to shut down, to start sheltering in place. And you can see that they've got some real data. So right about the beginning of April is where they reach their vertex. So if I draw a line, you can kind of see that parabola right there. And they are decreasing, so they're looking at being able to release the, release the numbers, let people out of their houses. All right, but we're looking at this quadratic function, and I wanted you to see that what they did, this is the average, that if I trace the averages, that it does make that quadratic function. This is the vertex up here, and this is where the direction begins to change when we start heading back to normal. I am not a scientist. I'm a math teacher. I am not an epidemiologist. I do not study diseases. I just know algebra, so I am explaining this not from an expert standpoint, but just so you can see the algebra as it relates to our real life. So we started out with an exponential. By the time this is over, we should be seeing that quadratic curve where there is a direction change. The main thing for you to understand about quadratic functions is they reach a peak either at the top or at the bottom, and they change directions. And the axis of symmetry, you can guess, all right, so basically this is where you would make your prediction. So however long it took to get from the beginning to the peak is how long you would expect. So it looks like this took 5 weeks. If the curve continues on this quadratic function, then it's going to be 5 weeks on that side as well. And this is looking at a quadratic function in a real world situation that we happen to be living through here in 2020. Just thought that would make algebra a little bit more real. It certainly has just done that for me. All right, well, stay inside, stay healthy, wash your hands, and hopefully this helped you to understand quadratics in the real world. Thanks for listening.